In this video, we're going to review our work with law of sines and law of cosines. So one of the things that we're going to need to be able to do is recognize when we use each of our two scenarios. So when it comes to law of sines, what we always want to create is an angle opposite side pair where we have both values for the side length and its opposite angle. That's going to occur when we're given angle side angle or angle angle side. And since those are congruence methods, we know only one triangle can be formed. The other time we get this angle opposite side pair is when we're given side side angle. Now the problem with this is that it's not a congruence method, and we saw that that extra side that's not hinged can kind of just swing and float however it wants. So that could mean that we either create one triangle, two triangles, or it's not even long enough to make a triangle and we get no triangle formed. So we really have to be careful when given side-side angle. Even though it gives us an angle opposite side pair, it might not give us a triangle that we want, or it might not give us just one triangle. For law of cosines, what we're going to do is still be given some three parts of our triangle to help us solve, and we're going to always have at least one side length so that we have a reference to how big or how small our triangle is. So for law of cosines, we're not going to get an angle opposite side pair. So we're going to be given three pieces like side, 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 or we're going to be given two sides and the included angle. These are both congruence methods, so again, only one triangle is going to be able to be formed. When we're given side, 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 what we're going to do is we're going to solve for an angle. And I recommend finding the angle opposite the largest side first, because the triangle inequality theorem tells us that the largest angle in a triangle is always going to be opposite the largest side. So if I use law of cosines, I'm going to be able to figure out if I get an obtuse angle right away, and I'm not going to have to worry about that ambiguous case because a triangle can only have one obtuse angle. And if the angle opposite the largest side is acute, well, then I know the other two angles are just going to be smaller acute angles than what I found for my first one. So I always recommend finding the opposite the opposite angle from the largest side. For side angle side, we're going to find the missing side length first, and it's going to be the side that's opposite that given angle. So as we're working through, when your goal is to solve a triangle, we've done it in isolation. So we always knew, hey, this is a law of sines practice worksheet, so we're going to use law of sines. Or, hey, this is a law of cosines worksheet, so we're going to use law of cosines. Here they're going to be mixed up and you're going to have to decide. So what I always look for is that angle opposite side pair. And if I see that angle opposite side pair, then I know I can use law of sines. And in this case, I had angle A was 31 degrees and the side opposite was 14. We wanted to solve the triangle, so that meant we wanted to find the other two sides and that missing angle B. So I just jumped right in and I used my law of sines to work this out. So you could jump right in and find your length. I called AB X, and that was opposite that given side of 36. So I said X over sine 36 equaled 14 over sine 31 degrees. And then I just multiplied both sides by that sine of 36. Again, I always like to put my unknown in the numerator of my first fraction so that in one quick algebraic step I can isolate my variable. I rounded to the nearest tenth and found out X was about 16 feet, and that was my side length AB. Then I went ahead and I solved for my y. Now, in order to get y, I needed the angle opposite that, which was angle b. So I just went back to my good old friend, the triangle sum theorem, and I know that all three angles in a triangle add up to equal 180. So I added up the two angles they gave me, subtracted from 180, and found out angle b was 113. So now that's my opposite angle from y. So I said y over sine of 113 equaled 14 over sine of 31 degrees, and again multiplied both sides by that sine of 113 degrees to clear the fraction, and found out y was about 25. So then that meant side AC was 25 feet. So super simple. Anytime I'm given that angle opposite side pair, I'm going to jump right in and do my law of sines. When I don't have an angle opposite side pair, that's when I'm going to use my law of cosines. So Letter B here, I was given three sides. So obviously, if there's no angle given, then I obviously don't have an angle opposite side pair. So what I did was I drew my picture, and I should have labeled all three sides, but I didn't. So I'm going to go ahead and label this EF over here as 14. And so when I'm working with side, 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 and I know I'm going to be using my law of cosines, what I'm going to do is find my largest side. And I'm going to solve for the angle opposite that first. Because again, we know that in quadrant one, all of our ratios are positive, but in quadrant two, cosines ratio is negative, and that's where my obtuse angles live. So if I do an inverse cosine for a negative ratio, I'm going to get my obtuse angle. And that's what happened in this diagram right here. So when I found that side, I took my 18 squared, that's the side I chose. I take the other two sides, square them and add them, and then subtract 2 times the product of those two side lengths, and then multiply it by the cosine of the angle opposite the side I picked. So the angle opposite, that's an 18 there, was angle E, so I'm putting angle E there. Now remember, once I set up my law of cosines, I'm going to go ahead and try to clean up all those squared numbers. So I went to my calculator and found out 18 squared was 324. These are both constants, so I squared them and added them together to get 232. And then I can multiply all of these together, and I got minus 168 cosine E. These are not like terms, so I can't combine them, but I could subtract that constant over to the other side to get all my constants together. So that's what I did. So now I have 92 equals negative 168 cosine E, and I want to get cosine E by itself. So I divided both sides by negative 168. And here's where the magic happens, because now I have a negative ratio. And if I do the inverse cosine on both sides, I'm going to be able to find angle E. And when I did that, I got angle E to be 123.2 degrees. So now that can be the only obtuse angle in this triangle. So when I switch over to law of sines, it's not ambiguous anymore, because now once I go to solve it, the angles that are left have to be acute. So everybody's living in quadrant one once I do that. So once you get one angle, you still want to try to find the remaining. It doesn't matter who you go to next. I tend to just always go from biggest and then go switch over to the smallest. So I happen to just jump over to the side length of 6. And now I'm going to use law of sines, because now once I found that angle E, I created that angle opposite side pair that I need for law of sines. And I went ahead and set up, and I did sine of F over that side length of 6 was equal to sine of 123.2 from the angle I just found over here over that side length of 18, multiplied both sides by 6, took the inverse sine, found out angle F was 16.2 degrees, and then after that, just used my good old triangle sum theorem to find angle D. So when you're working through these problems, that's what you want to do. Figure out whether we're using law of sines or law of cosines. If we don't have an angle opposite side pair, we're going to use law of cosines. And if we do have an angle opposite side pair, we're going to use our law of sines. And we just have to be careful and make sure we don't get trapped with that ambiguous case.